Dear friends, myself, Mr. S.R. Sirsagar, presently working as an assistant professor in Department of Chemistry at Rayat Shikshan Sanstha's Dada Patil Mahavidyalaya Karzat, District Ahmednagar. Today, I will discuss topic number 4, Quantum Chemistry, Lecture 1, from CH 341, Physical Chemistry, Same 4, for TY B.Sc class. So, let us see outline of the topic. Point number 1, introduction. Point number 2, applications of quantum chemistry. Point number 3, Planck's quantum theory. Point number 4, concept of quantization. Point number 5, frequency, wavelength, wave number, energy and its interrelationship. Point number 6, atomic spectra. Point number 7, wave particle duality. 8, Heisenberg's uncertainty principle. 9, wave function and its interpretation. Point number 10, well-behaved function. Introduction. Classical mechanics, discovered in 17th century by Isaac Newton, and it is based upon Newton's law of motion. It is applicable to planets and everyday objects such as pendulum, projectiles, etc., but fails to explain experimental behavior which are discovered in 19th century like black body radiation, photoelectric effect. These result leads to develop quantum mechanics, or in other words we can say that quantum chemistry, which is a branch of science which deals with the study of atomic and molecular properties and behavior of matter on microscopic scale. Quantum chemistry has large number of applications. It deals with to solve some problems related to physical chemistry such as interpretation of molecular spectra, experimental determination of molecular properties, to calculate properties of transition state in a chemical reaction. In organic chemistry, to estimate the relative stability of molecule, investigate the mechanism of reaction, predict aromaticity of a compound, as well as in inorganic chemistry, predict and explain the properties of transition metal complex by using ligand field theory and approximate mechanical methods. So we can calculate also molecular orbitals and their energy, electron density, molecular geometry, relative stability of two molecules, NMR shapes, IR and Raman frequency and normal modes, electronic transitions, associated changes in electron density, optical rotation, conductivity, ionization potential, electron affinity, heat of formation, transition states, activation energy, charge distribution, in interaction energy between two molecules, solvation energy pK. Max Planck is the father of quantum chemistry. In 1901, Max Planck initiated quantum physics by presenting his quantum theory. He was awarded Nobel Prize in Physics in 1918. And he put forth one theory, so that theory is called as quantum theory. Energy is not emitted or absorbed continuously. It is emitted or absorbed in the form of packets or bundle, is called as quantum. In case of light, quantum of energy is often called photon also. The amount of energy associated with quantum of radiation is directly proportional to frequency of radiation. E is directly proportional to mu. E is energy, mu is frequency. In order to neglect proportionality sign, we have taken one constant. So this constant is called as H. H is Planck's constant, was having value 6.626 into 10 to the power minus 34 joule a second. And therefore we can write E is equal to H mu. A body can emit or absorb energy only in terms of integral multiple of quantum or photon. So it can be represented as E is equal to NH mu. N is integer, integral multiple, 1, 2, 3, never fractional, never zero. So quantization of energy refers to absorption and emission energy in the form of discrete packets or quantum. As intensity of electromagnetic radiation decreases or increases, its step up or down from one quantized level to another, rather than follow a smooth and continuous wave. Establishment of energy of quantization is called as replacement of classical mechanics. Energy of quantization under the three main categories: black body radiation, heat capacities, atomic spectra. So let us see a person climbing from state A to state B. by two paths. One is by using steps of the staircase, another is continuous path. When person is climbing from by using steps, his position can be told in terms of he is in first steps of the staircase, he is on second steps of the staircase, he is on third steps of the staircase. But while he was climbing, or while he was climbing by this path, his position can be told in terms of height. He is 10-meter height from earth, etc. So discrete energy levels are compared with the steps of the staircase, and it leads to the concept of quantization. Wavelength. So distance between two successive crusts or two successive trough. Distance between two successive crust or two successive trough is called as wavelength, and its unit is meter. Frequency. So number of waves passed through the fixed point per unit time in a 1 second is called frequency. Its unit is hertz, and 1 hertz corresponds to energy and wavelength. Since mu is directly proportional to 1 upon lambda, in order to neglect proportionality sign, we have to take one constant. So that constant is c. So mu is equal to c upon lambda, where c is velocity of light, whose value is 3 into 10 to the power 8 meter per second. According to Planck's quantum theory, E is equal to h mu. Therefore, instead of we substitute mu here its value, so we got E is equal to hc upon lambda. Greater the wavelength of radiation, lower will be its wave number. The reciprocal of wavelength is called wave number. Its unit is per centimeter. Energy and wave number are also related to one another. Mu bar is equal to 1 upon lambda. Therefore, when we substitute value of mu bar in above energy equation, we got E is equal to hc mu bar. Thus, energy of radiation is directly proportional to the wave number. Atomic spectra, the particular pattern of wavelengths absorbed or emitted by element. Wavelengths are well separated. Wavelengths vary from one element to the next. Atoms can only exist in few states with specific energies. When light is emitted, the atom goes from higher energy state to lower energy state. Consider simplest example, hydrogen. When we pass electric discharge or when we heat hydrogen at high temperature, you will get series of lines obtained in the spectrum like Balmer series, which is colored series found in visible region, Lemon series, Paschen, and Rydberg formula. Balmer was correct. The Rydberg formula combines all of these series into a single formula. 1 upon lambda is equal to R, 1 upon nf square minus 1 upon ni square. Where nf and ni are integers. Ni is equal to na plus 1. The Rydberg constant R is 1.0973 into 10 to the power 7. Spectral series of for hydrogen. So first one is Lemon series observed in ultraviolet region. Its expression can be written as 1 upon R, 1 upon spectral series for hydrogen. So Lemon series observed in ultraviolet, its expression should be 1 upon lambda is equal to R, 1 upon 1 square minus 1 upon n square, n is greater than or equal to 2. For Balmer series observed in near UV and visible, 1 upon lambda is equal to R, 1 upon 2 square minus 1 upon n square, n is greater than or equal to 3. For Paschen series observed in infrared region, so 1 upon lambda is equal to R, 1 upon 3 square minus 1 upon n square, so n is greater than or equal to 4. For Bragg series, it is observed in infrared, 1 upon lambda is equal to R, 1 upon 4 square minus 1 upon n square, n is greater than or equal to 5. For Fund series, that is observed in infrared, its expression should be 1 upon lambda is equal to R, 1 upon 5 square minus 1 upon n square, n is greater than or equal to 6. So different lines obtained in the spectrum of hydrogen atom. So the spectrum is emission type. Wave particle duality of a light. In 1924, Einstein wrote that now light has two natures. So first one is wave nature of light. So that is described by diffraction interference. But evidence for particle nature was given by photoelectric effect and component scattering. Now light behave sometimes like a wave, sometimes like a particle, so-called wave-particle duality. In 1923, Louis de Broglie suggested that electron looks like a particle, why it has not wave nature, and he assumed certain assumptions. Nature has symmetry, energy and mass interconvertible, and wave associated with particle is particle wave, and he derived a famous equation: lambda is equal to h upon p. Lambda is the wavelength of light, p is a momentum, lambda is a characteristic of wave, p momentum is a characteristic of particle, so called wave particle duality of an electron. And he was derived this equation as E is equal to h mu, and mu is a frequency, and that will be written as c upon lambda. So E is equal to hc upon lambda. So rearranging this equation, instead of velocity of light we have to wrote instead of velocity of light we have to wrote their velocity of particle. So lambda is equal to h upon m into v, and m into v is a momentum. So therefore lambda is equal to h upon p. So this wave particle duality was supported by electron diffraction pattern experiment, was performed by Davidson and Germer, and he was carried out experiment on first diffraction pattern of nickel, and after studying that diffraction pattern they have suggested that light electron behaves sometimes like a light, sometimes like a particle, so called wave particle duality. And wave particle duality is applicable to only microscopic particle, not to the macroscopic particles like a golf ball. Those particles which are invisible to our eyes, in such a case wave particle duality is applicable, but those particles which are visible to our eyes, we can't apply that. So lambda is equal to h upon m into p, h upon momentum, and lambda is inversely proportional to the momentum. So one bullet has such a large momentum, larger the momentum, smaller the wavelength. So wavelength of a bullet, a brilliant billiards ball, or any object in the microscopic world, so negligible so that we can't notice it. So summary of wave particle duality of wave particle duality of light was supported by interference as well as photoelectric effect. Wave particles will be supported by matter waves of electron microscope, and particle nature will be supported by photoelectron collisions, and light behave like a wave, like a particle, particles behave like Uncertainty principle is significant in microscopic particles like electron, proton, neutron, which are not visible to our eyes. But those particles which are visible to our eyes, such particles are called as macroscopic particle. So for macroscopic particle, it is not applicable. Wave function. Wave function is a mathematical function. So it is defined as wave function is a mathematical function which is a function of coordinate part of system and time. It is represented as a psi. And wave function for one direction is written as psi x. Wave function for three direction can be written as psi x, y, z. Psi may be time dependent, therefore psi x, y, z is the wave function. So wave function is sometimes positive, sometimes negative, sometimes zero. Therefore, it is complex. And in order to write the neglect the complexity, we must use mod psi square instead of psi. Mod psi square is equal to psi into psi star. Psi is a complex conjugate of psi. Psi star is a complex conjugate of psi. And psi and psi star both are same, but its value I is equal to under root of -1 for psi. It is under root of minus plus for psi star. Mod psi square is the probability of finding electron around the space. So condition for valuable function. The wave function which follow certain conditions such as psi must be single valued, continuous, finite, normalized, zero at infinity. If any wave function satisfied this condition, such wave functions are called as well-behaved functions. So as to give explanation, we will consider diagram A. In a diagram A, so wave function is not continuous, therefore it is not acceptable. In a diagram B, wave function is continuous, but it has different values. Here it has one value, here it has another value, therefore it is multi-valued, not acceptable. In a diagram C, so again psi must be continuous, then it has different values. Here it has one value, here it has another value, here it has another value. It becomes multi-valued, it is not acceptable. And if we consider D, at 0 it must be, at infinity it must be 0, but it will shows at infinity certain wave function, therefore it is not acceptable. Thank you.